Hello everyone. Did you know that in 2025, global sugar consumption reached 178 million tons, of which sugar from sugar beets accounted for 40 million tons? But how is sugar produced from this unusual root crop? Today, join us as we explore the journey of cultivation and harvesting, as well as how a factory produces millions of tons of sugar each year from sugar beets. About 250 years ago, people discovered that sugar could be extracted from sugar beets. In 1747, the German chemist Andreas Sigismund Marggraf proved that sugar from sugar beets is no different from cane sugar. While sugar cane only grows in tropical regions, sugar beets can thrive in colder areas and less fertile soils, opening opportunities for regions that cannot grow sugar cane but can cultivate beets. By the early 19th century, sugar beet processing factories began appearing in Northern Europe. In England, more than 2 million tons of sugar are consumed each year, and surprisingly, more than half of it is produced from sugar beets. This has made sugar beets an important source of sugar in many countries. Everything begins in spring, when the fields awaken from winter dormancy and are prepared for planting. Farmers work with crop specialists to plan sowing, select varieties, and test the soil. For sugar beets to grow best, the soil must contain sufficient potassium, nitrogen, and phosphorus. The soil also needs proper moisture so the beets can grow vigorously, drawing nutrients from deep underground thanks to their long taproots. From tiny seeds, these seeds are carefully nurtured, planted, and meticulously cared for to grow strong. Beet fields are precisely sown by machine. 1 hectare of land can contain up to 100,000 beet plants. Each row is carefully spaced to ensure the plants have enough room to develop strong roots underground. In the weeks after planting, young seedlings begin to emerge evenly across the field, forming neat green lines. Farmers closely monitor early growth, managing weeds, moisture, and soil conditions to support healthy leaf development. This careful attention during the first growth stage plays a crucial role in determining the final sugar yield. Strong, uniform plants at this stage lay the foundation for a productive harvest months later. After about 180 to 210 days, sugar beets reach ideal maturity through the process of photosynthesis. The beet plant absorbs sunlight and converts it into chemical energy, helping store sugar in its root. In addition, sugar beets require a large amount of sunlight to synthesize sugar efficiently. Sunlight converts CO2 from the air, together with water and nutrients from the soil, into sucrose. The beets then store this sugar as an energy reserve in their roots. The beet plant can contain about 20% sugar. It also produces oxygen, with each hectare generating enough oxygen for 100 people to breathe for an entire year. Sugar beets are harvested from September to February of the following year at more than 3,500 farms in eastern England. When the beets reach optimal size and sugar content, harvesting begins. In Norfolk, processing factories can handle up to 3 million tons of sugar beets each year, accounting for 2/3 of England's production. On average, about 7 beets are needed to produce 2 pounds of sugar. When harvest season arrives, it is not simply a matter of pulling the beets from the ground. To obtain optimal sugar yield, harvesting must be carried out in a way that keeps the entire beet intact. Each beet weighs an average of 2 pounds, of which 17% is sugar, 75% is water, and 8% consists of other substances. The processes of harvesting, transportation, and processing run continuously day and night. Modern harvesters can simultaneously harvest 6 rows of beets. Special blades cut off the leaves, preserving the valuable root. After the beets are lifted, they are transferred to a cleaning system, where 13 rollers remove soil and impurities clinging to the beets. These harvesters can collect more than 25 tons of beets per hour. After harvesting, the beets are temporarily stored at the edge of the field before being transported to processing factories to be turned into sugar. At the factory, the beets are inspected, weighed, and ensured to meet input quality standards. First, the beets are fed into a rotating drum, where under sprayed water, they rub against each other to remove dirt. The water flow helps the beets float upward, after which they exit the drum. Stones are retained and collected in separation bins along the edge of the rotating drum. However, leaves are still mixed with the beets. The beets are fed into another rotating drum, operating like a giant washing machine. Once the beets are completely cleaned, they are cut into smaller pieces. The sharp blades of the cutter slice the beets into thin chips like potato chips. These thin slices move on a conveyor into a large hot water tank, where they are soaked for several minutes. This causes the beet cell membranes to begin opening, facilitating sucrose extraction in the next steps. At this stage, the beet strips are transferred to the bottom, about 20 meters extraction tower. A rotating shaft inside the tower slowly carries them upward against a downward flow of hot water at 72 degrees Celsius. This process lasts about 90 minutes, extracting nearly 90% of the sugar from the beets. The resulting sugar solution is called raw juice. The remaining beet pulp after extraction is pressed into pulp and used as animal feed. The next step is refining this raw juice. Calcium hydroxide, also known as milk of lime, is added to the solution in multiple stages. Then CO2 gas is introduced into the mixture, helping absorb impurities and allowing the sugar solution to be filtered clean. After filtration, the raw juice becomes a light yellow dilute sugar solution. The dilute sugar solution continues through a 6-stage evaporation process, producing a thick syrup containing 67% sugar. To create white sugar crystals, seed crystals are added to the thick syrup and stirred evenly, then slowly cooled so the sugar crystals grow uniformly. After about 3.5 hours, the crystals reach standard size and are separated from the molasses by centrifuge. The molasses solution is also used in animal feed production. The sugar crystals are then washed with hot water to increase purity, dried, and passed through a screening machine to remove oversized crystals. These crystals are dissolved and sent through the crystallization process once again. And finally, this is the end product of a large-scale sugar production process. After drying and quality inspection, the sugar is packaged and prepared for shipment. This product not only serves the daily needs of consumers, but also supplies raw materials for the food processing industry, helping foods and beverages become sweeter and more appealing, contributing to the global food industry. And so we have explored the journey from sugar beets to the pure sugar crystals found in everyday products. If you found this video interesting and useful, don't forget to like, subscribe, and turn on notifications so you won't miss the latest videos about unique and fascinating production processes from around the world. Thank you for watching, and see you in the next videos.